Hello friends, today we will learn about extent of reaction and basics of stoichiometry. As we all know, chemical reaction plays a vital role in chemical reaction engineering or in general chemical engineering. So it is very important to learn the basic stoichiometry. And as we all know, any reaction is of the form alpha A plus beta B, which gives PC plus BD. In reality, every reaction is in slight equilibrium or highly equilibrium that depends on temperature. And A, B, C, and D, these are the species. And alpha, beta, small c, small d are the stoichiometric coefficient. Now, suppose initially in system Na naught, Nb naught, Nc naught, and D naught moles are present initially, and we want to find after certain time what will be the moles in the system. Now to do that we will use a variable called extent of reaction, extent of reaction, which is which you can think of a coordinate. Like extent of reaction 0 means it has not proceeded some value, it has proceeded to some value. Just like in x coordinate we define x as some x value as from 0 to some x meters, we consider it as x value or some unit. Just like that, it has extent of reaction, which is unitless, a variable which determines the extent. Now, to use this, we will write Na naught minus alpha epsilon, Nb naught minus beta epsilon, Nc naught plus C epsilon, and Nd naught plus epsilon d. Now, one thing to note that in case of a reactant, this sign will be negative, this sign. In case of a product, this sign will be positive. So it means that from NaO, Na naught moles, this amount is getting consumed. From Nb naught moles, this amount is getting consumed, and in Nc naught moles, this amount is getting added. These are added. So this is the final or after certain epsilon. It means that after certain epsilon, these are the moles in the system. Now, suppose we want to write the conversion of A, species A. Now, by definitions, the species A conversion is given by how many moles it has consumed or destroyed in reaction, which is equals to Na naught minus Na divided by Na naught. Na naught is the initial mole. This is the extent of reaction. Also, let me write one thing. This value is Na. This is Nb. Wait 1 minute. Let me write it properly. This is Nb. This is Nc. This is Nd. Now to write a conversion of A, we will write how many moles is consumed divided by initial moles. Now we can see how many moles consumed is this much amount is consumed. So we can directly write alpha epsilon divided by Na naught. But we will write it like this: Na naught minus Na naught minus alpha epsilon divided by Na naught, which is equals to, sorry, which is equals to alpha epsilon divided by Na naught. So directly we get this formula. Uh, So directly we get this value without uh, much of complication. 1 minute. Uh, so, NA0. So from here we can write that extent of reaction excellent in terms of conversion of A is given by exit time Na0 divided by alpha. This is this is very this we will use again this expression. Okay. Now suppose as I have said that initially Na0, Nb0, Nc0 moles are present in the system, and after finally Na, Nb, Nc, and D are there. Now suppose we want to somehow relate initial and final total moles, and from that total moles we will use some other kind of expression which will be is very useful in CRE, like what will be the final total moles? Sorry, the total final moles N is equals to Na plus Nb plus Nc plus Nd. Now let us use the values of Na as Na0 minus alpha epsilon, Nb as this value, Nc as this value, and Nd as this value. Let us see what expression we get. Na0 minus alpha epsilon plus Nb0 minus beta epsilon plus Nc0 plus T epsilon plus Nb0 plus epsilon D. Now we can see that Na0, Nb0, Nc0, and D0 we can write it as separate term. Sorry, Na0 plus Nb0 plus Nc0 plus Nb0 plus and taking epsilon as common epsilon, we will get P plus D minus alpha minus beta. So from these expression, we can say that this quantity is total initial moles. Okay, so we will write it like this: N naught, which is total initial mole, plus this C plus D minus alpha minus beta is the difference in the total stoichiometric coefficient. C plus D alpha and beta. C plus D minus alpha minus beta. So we can write this as a difference of stoichiometric coefficient, which we can write as some, we will write it as delta. Let us write this difference in stoichiometric coefficient as delta. C plus D minus alpha minus beta. Delta is equals to C plus D minus alpha minus beta. So N naught plus epsilon delta. Okay. Now, so we get an expression which represent which represent this value. So initial moles and final moles are related by epsilon into delta. Now also another thing, suppose we want to write this quantity in terms of extent of reaction. So we will write it uh, sorry, the extent of reaction zeta in terms of conversion n naught plus xa na naught divided by alpha into delta. So this is the quantity, and this can be again written as n naught by taking common 1 plus xa delta na naught divided by n naught to 1 by alpha. Now see this quantity carefully. This n naught na naught by n naught, it can be written as the mole fraction, which is initial mole fraction. So 1 plus xa, x is the conversion, delta by alpha. Delta is the change in stoichiometric coefficient. Alpha is the stoichiometric coefficient of the species which we are defining for as a conversion. And Na naught by No is initial moles. Call it Ya naught. So this is a very important expression, and I suggest everyone should remember this. This is a kind of shortcut. This expression, this expression, you can use it like a shortcut. Okay? This expression, this expression, it can be used as a shortcut. Now, let me write it properly. So this expression n is equals to n naught 1 plus xa into delta by alpha into ya naught. This is very useful expression where delta is change in stoichiometric coefficient, change in stoichiometric coefficient. And with this expression, you can do many sums in TRE, point process calculation. Suppose now let us take a case. Suppose initially Na naught, Nb naught, whatever the species we have considered. Wait a minute. Hmm. Suppose suppose in the system Na naught, Nb naught are present, Na naught, Nb naught, Nc naught, Nd naught. These are present at certain, suppose temperature naught, P naught, and V naught. Volume. These are occupying this. These are having T naught, P naught temperature pressure and occupying volume T naught. Suppose these are gases. Now, after reaction, heat may generate or some external agent may give heat, and after the reaction, Na, Nb, Nc, and Nd moles are present at TPV. These are the thermodynamic variables TPV, which defines the state after the reaction. So how can we relate the temperature pressures of the initial state and the final state? We will use simple ideal gas law, assuming these gases follow ideal gas law. E naught V naught is equals to N naught R T naught. Now remember this N naught is the summation of all Na naughts, like N naught is equals to Na naught plus Nb naught plus Nc naught plus Nd naught, and N is the summation of Na, Na plus Nb plus Nc plus Nd, which is again equals to N naught in terms of, I am writing in terms of conversion of A, capital A, delta by alpha yn naught. Now, this is the expression initial. Initial. After final reaction, suppose heat is there and it is in equilibrium. So we can write the final thermodynamic uh, equation of state as nRT. Now, to get relation, we will divide this equation. Nt by n naught T naught is equals to PV by P naught V naught. Now, n by n naught, we know this n by n naught, this quantity, which is this n divided by n naught, is 1 plus xa delta by alpha initial moles into temperature by temperature naught is equals to PV by P naught V naught. This is the relation. Now, in many cases, temperature pressures are fixed. In many textbooks like 11th sphere Fogler, in 11th sphere Fogler, the temperature pressures are fixed. If suppose temperature pressures are fixed, T is equal if suppose if T is equals to T naught and P is equals to P naught, then we get a change in volume reaction which is equals to V by V naught 1 plus XA delta by alpha YA naught. This is a very familiar expression and we can see it in many textbooks. These volume change at same initial temperature pressure, we can define the conversion or extent of reaction. So this expression is also an important expression. There is no need to remember. Only thing you need to remember is this expression. This n is equals to n naught plus 1 plus conversion of A, which we are using species. If we are using species A as A, then conversion of A. Delta is the change in stoichiometric coefficient divided by the stoichiometric coefficient of the species which we are choosing as A, that is A corresponds to alpha and initial mode. So this expression, if we remember, we can solve many problems. We generally in questions initial moles is given. Initial mole fraction of the limiting reactant. I will also tell how to find the limiting reactant. It is also given. Reaction is known. So this value can be calculated and everything can be calculated, and in terms of conversion of A, then the life becomes very easy if you remember this expression. Now, as we have chosen A, we have to know how to choose limiting reactant. Now, limiting reactant, suppose, let me tell,